Hi children, today we are going to learn 6th class, 3rd chapter, that is playing with numbers, in that exercise number 3.7. So in this exercise we are going to discuss the divisibility rules of 4, 8 and 11. So you have to learn the divisibility rules. That video already I have done. You have to watch the video so that you will know what is the divisibility rule of 4, 8 and 11. So without wasting time, let's start the class. First question, which of the following numbers are divisible by 4? So here there are 5 internal questions. Let us see the first one, that is 572. So let us check, is this number is divisible by 4 or not? So if you want to check a number is divisible by 4, not to check a complete number, dividing and checking, so just take the last 2 digits. The last 2 digits is what? 72. Let us check if the 72 is divisible by 4 or not. Yes. Here 4 ones are 4, 3 will left, and bring down this 2 here. 4 adds are 32. As remainder is 0. Yes. This 72 completely, the last 2 digits is divisible by 4, and the complete number is divisible by 4. As 572 is divisible by 4. So we have to check only last 2 digits. If last 2 digits of a given number, if at all it is divisible by 4, else the complete number is divisible by 4. Let's see the second question here. 21,084. What are the last 2 digits? That is 84. Let us check that is 84 is divisible by 4. Yes. 4 2s are 8 and 0. Here we will bring down of 4. 4 1s are 4. And the remainder is 0. Here also symbol, that is 21,804 is divisible by 4. So the remaining problems of this exercise you have to do it in the same way. Only you have to check the last 2 digits of the given number. If it is divisible by 4, hence the complete number is divisible by 4, or else it is not divisible. Let's see the second bit. So test whether the following numbers are divisible by 8. Here also there are 5 internal questions as like in the first bit we have done. So let us check here 2 of the problems. Let's take the first problem, that is 9,774. Is this number is divisible by 8 or not? To check the divisibility rule of 8, the last 3 digits must be divisible by 8. So let us take, what are the last 3 digits here? 774. Is this number is divisible by 8? Let us check. Here, first of all, 8 9s are 72. 77 minus 72, that is 5. Here let us bring down the 4. Yes. Now, what we do it? See, 8 6 are 48 is possible. 8 7 are 56. Okay. Here, what we get? 6 as the remainder. We get it? 6 as the remainder. So the remainder is not 0. That means here 774 is not divisible by 8. The last 3 digits of this number is not divisible by 8. Hence we can conclude that the 9,774 is not divisible by 8. Then the complete number is not divisible by 8. Let me take the another question. Please. Second one. Yes. 5,31,048. So what's the last digit here? The last 3 digits are 048. 048. So let us check here 048. Is it divisible by 8 or not? So 0, 8 zeros are 0. So let us bring down this 48 directly, because 0 has no value. So let us go for that. Now 48. Directly I put it here. Then let us divide this 48. 8 6 are 48. Simple. Hence, completely this 5,31,048 is divisible by 8. Simple. In this way, we can check a given number is divisible by 4 and 8 or not. If it is divisible by 4, the last 2 digits must be divisible by 4. If it is divisible of 8, the last 3 digits must be divisible by 8. And remember that if a number divisible by 8, it is also divisible by 4. Suppose this number is divisible by 8 now. So you check this number is also divisible by 4. Now, there will be some more conditions. If a number is divisible by 4, it may divisible by 8 or may not be divisible by 8. For this, you need to see the divisibility rules. Okay, you have to watch the one more video, divisibility rules video, so that you can understand. Here the third bit, check whether the following numbers are divisible by 11 or not. You know what is the divisibility rule of 11? The difference of sum of even digit places and odd digit places. If it is a multiple of 11, then it is a divisible by 11. So let us check that. The third bit, first question. Yes, 8,59,448. So, sorry, 484. Is it number divisible by 11 or not? To check that, we have the divisibility rule of 11, the sum of odd digit places. The sum of odd digit places. Sum of odd digit places. That means the sum of odd digit places are what? Let us see. Here odd digits. 1's place and the 3rd place and 5th place. These are the odd digit places. So let us add it here. 4 place, 5. What you got the sum here? 4 plus 4, 8. 8 plus 5 is 30. Now, sum of even digit places. Sum of even digit places. The sum of even digit places are these: 4, 9 and 8. Sorry, 8, 9 and 8. 8, 8, 16, 16 plus 9 is 25. Now the difference between them, the difference 25 minus 13. 25 minus 13 is 12. Is this 12 is divisible by 11 now? No. 12 is not divisible by 11 exactly. So here we can conclude that, okay, here 8,59,484 is not divisible by 11. Very simple. So let us see the other question from this textbook only. We have the second one here. Let's check the second question. 10,824. If this number is divisible by 11, let us check that. First of all, sum of odd digit places equal to all digit places 4, 8 and 1. 4 plus 8 plus 1, that is 13. Yes, sum of even digit places. Sum of even digit places, that equal to 2 plus 0, that equal to 2. Now the difference 13 minus 2 is 11. Yes, is this 11 is divisible by 11? Exactly, 11 ones are 11. So therefore here 10,824 is divisible by 11. The remaining questions from this bit you need to do it, as well as the remaining questions from first and second bit also you need to do it. Here there is one more bit, your fourth bit. Let us complete this also. Yes. Verify whether the following numbers are divisible by 4 and by 8. Here he asked, verify the following number divisible by 4 and 8. Both we have to check. So here we have to check the divisibility rule of 4. If a number divisible by 8, it's also divisible by 4. So first of all, let us check. First number is what? 2104. Is this number divisible by 8 or not? Let us check first. The divisibility rule of 8. Let us check the last 3 digits. The last 3 digits equal to 104. Let us check this. Is this 104 divisible by 8? Yes. 8 ones are 8. 2 left. 24. 8 threes are 24. Yes. The last 2 digits, the last 3 digits are divisible by 8. Hence, here 2104 is divisible by 8. If a number divisible by 8, we not to check. It's also divisible by 4. Hence, we can also write 2104 is also divisible by 4. If this number is not divisible by 8, then we have to check the divisibility rule of 4 again. Once again, if it is not divisible by 8, then you check that number is divisible by 4 or not. But if this number is divisible by 8, not to check the divisibility rule of 4 directly. However, it is divisible by 4. Directly you can write the answer, or not you can check and find out. Let me see the next question. The second question, 7,26,352. Is this number divisible by 4 and by 8 or not? Let us check. First of all, let us check the divisibility rule of 8. The last 3 digits are what? 352. Let us check. 352. Is it divisible by 8 or not? 8 4s are 32. 8 4s are 32. Then here you will get 3 and 2. 8 4s are 32 again. Hence, is this number also divisible by 8? Therefore, 7,26,352 is divisible by 8. Then if it is divisible by 8, not to check the divisibility rule of 4, because it is also divisible by 4. If at all it is not divisible by 8, there you need to check the divisibility rule of 4. Okay. Then already told you, if a number is divisible by 8, it's also divisible by 4. So there is one more problem in this bit. You have to check either that number is divisible by 4 and by 8 or not. Here the question number 5. Find the smallest number that must be added to 2,89,279 so that it is divisible by 8. So we have to find out the smallest number. The given number is equal to 2,89,279. So find the smallest number that must be added to this. Find the smallest number that must be added to this so that it is divisible by 8. So we have to check either first of all, is this number is divisible by 8 or not. The last 3 digits of the number. The last 3 digits of the number equal to what? 279. Let's check this 279 is divisible by 8 or not. 279. So 8 3s are 24. 3 left and this is 39. Okay, 8 4s are 32. 7. So you got the remainder as 7. So remainder you should get 0. If you write plus 1 here, it becomes 8. Then it's possible in 8 table. So if there is a, instead of 279, if you get a, this plus 1 we need to add. Instead of 279, if it is 280, then it is divisible exactly. Hence, the last 3 digits of the number 269. If we add this 1 to 200, if we have 1 to the 2,89,279, that becomes 2,89,280. Then it is divisible by, If we add 1, then it is divisible by 8. So what is the smallest number we are adding here? Therefore the smallest number must be added. The smallest number is 1, must be added to the given number, to divisible by 8. The smallest number, what is the smallest number we should add to divisible by 8? That is 1. If we add 1 to the given number, it is divisible by 8, or else it's not divisible by 8. The smallest number is not maximum number. Okay, then let us see some more problems are there again in the same way. Yes, sixth question. Find the smallest number that can be subtracted from 1965. This is question number 6. 1965. Find the smallest number that can be subtracted from this, so that it becomes divisible by 4. So divisible by 4 is what? The last 2 digits. Last 2 digits. 2 digits of the number of the given number is equal to 65. Is this 65 is divisible by 4? No. If you divide this 65, 4 ones are 4, 2 left here, 25, 4 6 are 24, 1 will be remainder. If this one you subtract from here, then it is exactly divisible by 4. If this one you subtract from the 65, then you will get 64. The 64 is divisible by 4. Hence, if we subtract 1 from the 1965, then it becomes 1964. It is divisible by 4. Then it is divisible by 4. Therefore, the smallest number we must be subtract. Therefore, the smallest number is -1, must be subtract. The smallest one number is 1, that must be subtract from the given number to divide exactly by 4 from the number 1, so that it becomes exactly divisible by 4. So let us see again. Total there are 9 problems. 6 problems we have completed. 3 more problems are left. Let us complete that 3 more problems also. Here the 7th one. Yes. What are the possible numbers between 1000 to 1100 that are divisible by 11. Okay, the possible numbers. Okay, write all the possible, all possible numbers which are divisible by 11 between 1000 to 1100. So between these, how many numbers are divisible by 11? That I need to write. Okay, let us write the numbers are. So the numbers are, see, 1000 is not divisible by 11. 1001, it is divisible by 11. See, the sum of odd digit places, 1 plus 0 1 and 0 plus 1 1. 1 minus 1 is 0. The 0 is divisible by 11. So this is 1. And add 11 to this number again. Add 11, simple. Add 11 here, 1 0. Here 11 you add it. If you add 11, it become a 12 here. Last two digits. Again you add the 11 here, it become 2 and this become 3. Again you add the 11, 3 and 4. 4, 5, 5, 6. 11 you add it continuously. 11 you add it continuously before the 11. 7 and 8. Here 8, 9. Okay, these are the numbers which are divisible by 11 between the 1000 and 1100. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers which are divisible by 11 exactly between 1000 to 1100. Okay, or not, you can check it here. 1 plus 0 1, 0 plus 1 1, 1 minus 1 0. 2 plus 0 is 2, 1 plus 1 2, 2 minus 2 0. 3 plus 0 is 3, 2 plus 1 3. 3 minus 3 is 0. The sum of even digit places and the sum of odd digit places and their difference. Yes, the difference of sum of even digit places and sum of odd digit places. Eighth one. Write the nearest number to the 1240. The given number what we need to do is, see, write the nearest number to the 1240 which is divisible by 11. So let us see what is the nearest number which is divisible by 11 to this. So first of all, let us see the sum of odd digit places and sum of even digit places and their difference. First of all, let us divide this 1240. Let us divide by 11. 11 ones are 11 here, that you get the 1, and here 4. Again 11 ones are 11, you get 3. 30 here. 11 twos are 22, that you got 8. 8 you got is the remainder. If you need here remainder as 0. If we get the remainder 0, it is exactly divisible. But we got 8. So that 8 you subtract from here. Then if you subtract this, then that means that 8 if you subtract 1240 minus 8, that equal to 1232. Is this a number exactly divisible by 11 first? So here 11 into this 112 is equal to 1232. Is this number first which is divisible by 11, which is nearest to this? And also let us see. Okay, let us add the 11 to this again. If you add the 11, 1243. Yes. Now we got these two numbers. See, these are the two numbers between, so before this and the after the 1240. So we have to choose which is the nearest number to 1240. Is this number is nearest to 1240 or this 1243 is nearest to 1240? Yes, we can say that 1243 is nearest to 1240. Yes, 1243 is nearest to the 1240. So what we need to find? write the nearest number. Therefore, the nearest number is the nearest number to 1240 which is divisible by which is divisible by 11 is 1243, not 1232. 1232 is some little far to 1240, but 1243 is very near to 1243. Sorry, 1240. So we got two numbers. From this, very nearest number is this, which is divisible by 11. Very simple. So the next and last question here. See the last question of this exercise. Write the nearest number to the 105 which is divisible by 4. The given number, therefore, the given number equal to 105. Okay, write the nearest number which is divisible by 4. Okay, which the number is divisible by 4. We know that exactly 4 into 25 is 100. Okay, or not? 4 into 26 is 104. 4 into 27, that is 108. So see, we got 105. Which is the nearest number? 108 or 104? This 104 is the nearest number to 105, which is divisible by 4. Simple. So therefore, the number, okay, which is 105, which is therefore the nearest number. Therefore, the nearest number to 105, which is divisible by 4 is 104. Here 108 and 100, which is far to 105, but the 104 is very near to 105, which is divisible by 4. I hope you understood this exercise number 3.7. It is based on only the 3 divisibility rules, 4, 8 and 11. If you know all the divisibility rules, this chapter is very easy to understand you. So thank you for watching this video. Thank you.